we begin with the depth function. We'll assume this is a depth function. Y equals 3t squared minus 34t minus 8. What we're interested in is the rate of depth change at the t equals 1 instant. We begin by finding the average rate of depth change between the t equals 1 and t equals 2 instant. Then between the t equals 1 and the t equals 1.01 instant. Once more, what we're looking at over here in this graph, we've plotted, okay, at t equals 1, we plug 1 into this function, we get negative 39 centimeters. We plug in 2 into the function, we get negative 64 centimeters. We plot the points 1, negative 39, 2, negative 64, and we see that the 1 second time interval is the run. The negative 25 centimeter difference in y is the difference in depth, and we're going to use that to calculate the average rate between t equals 1 and t equals 2. Then we're going to do the same thing between t equals 1 and t equals 1.01. It's going to give us a very tiny triangle over here, but as we've seen, that tiny triangle should be closer to the true slope at t equals 1 than this. When we do the calculations, we see that between clock times t equals 1 and t equals 2, we have a change of y from negative 39 to negative 64 centimeters, and that's calculated as delta y is negative 64 minus negative 39 centimeters. And of course a delta t that's from 1 to 2 seconds, 2 minus 1 seconds is 1 second. And we end up with an approximate average rate of change of negative 25 centimeters per second between t equals 1 and t equals 2. If we go between clock time t equals 1 and t equals 1.01, similar set of calculations gives us negative 39 centimeters, negative 39.2797 centimeters. So our delta y is negative 0.2797 centimeters divided by a delta t of 0.01 seconds gives us an approximate, well, it gives us actually an average rate of change of 27.97 centimeters per second. Now, there was an intermediate calculation which we haven't shown here, but if we go from t equals 1 instead of from 1 to 2 or 1 to 1.01, we go from 1 to 1.1, we find that the average rate of change is 27.7 centimeters per second. So we have a progression. With a delta t of 1, we have 25 centimeters per second. With a delta t of 0.1, it was 27.7. Compare that with 29.97. And with a 0.01 second interval, negative 27.97. What do we think is going to be the limiting value of this? Well, it should be fairly obvious that this is going to approach 28 centimeters per second, negative 28 centimeters per second.